Alright guys, so now in this video we are going to look at some more advanced features in Python, very important as well. So we'll be looking at how to manage collections of data. Then we'll look at conditional statements in Python, making decisions based on some conditions. And then finally we'll look at functions and then Lambda. So now, what is a data collection? So traditionally, what we've been doing in the previous video, we're storing one data item at a time. So for instance, if we store speed, it's equals to 100. Okay, this is one item being stored. Okay, what if we wanted to store multiple speed data? Okay, or let's say fruits is equal to apple. Okay, so what if you want to store multiple fruits? Okay, so we do that using collections. Okay, so this allows us to store more than one fruit in our variable. Now there are four types of data collection. Okay, 4 ways to store data collection. You can either use a list, you can use a tuple, you can use a set, and then you can use a dictionary. So we are going to look at these individual data collection methods, and then we'll look at how to use them, when to use them. We'll explore the various properties and then all that. So first, let's look at a list. Okay, so a list is basically denoted as this. Okay, and then we can store the items we are interested in. So apple, banana, okay, mango, then we can store melon. Okay, so this is a list. Okay, and then we can assign it into a variable fruits. So let me take this off. So this is a basic list. Okay, this is a basic list, and then I can print my fruits. Okay, and then when I run, okay, I should get apple, banana, okay, melon, and then orange. So this is a basic example of a list. Okay, so a tuple follows the same format. Okay, just that instead of using square brackets, okay, we will use a normal bracket. Okay, so this and then and that's okay, and then we can also print fruits, and then it should give us the same results. Okay, so you can also print sorry, not there. So and then it should give us the same results. So when we run, it should give us the same results. So fruits, list, fruits, tuple. And then we can also have that for sets. So set also follows the same, it's the same principle. Okay, but like we did in the list, okay, in the tuple, it also has its own way of denoting it. So we'll use a curly bracket. Okay, so apple, banana, mango, and then melon. Okay, so when we run, let me do this. Okay, then let me run, and then so you should have a list: mango, apple, and then so on. Lastly, for dictionaries, okay, dictionaries is a key value pair. It's a bit distinct from the others, but same format, just that you have to specify its key item. to make it different from a set, because you are also using curly brackets. Okay, curly brackets. Okay, so I have to specify its key. So it's a key value pair, so I have to specify its key. So first key is apple. Okay, then I have to specify another key, okay, to store banana. Then I have to specify another key, okay, to store mango. And then I have to specify another key to store melon. Okay, so for melon. Okay, so I have to print fruits. Print fruits. So I have to print fruits. Okay, and then yeah, so let me run it again. Good, there you have it. So 1 apple, 2 banana, 3. So now what you would ask, why they need to have all these different data collection types if they basically do the same thing? Okay, so the thing is that these data collection items, okay, though they allow you to store multi-data, they have their own individual properties. So you have to decide which one to use in any condition. So now let's look at fruits list first. So I would comment these print out. Okay, I'll comment them out. So for lists, okay, list has its own properties. So first of all, it's ordered. Okay, it's ordered. Okay, so let's say I bring banana. Okay, I bring banana here. Okay, I can sort this data. Okay, I can sort this data by using a property called sort. Okay, fruits.sort. Okay, so when I print fruits, okay, when I print fruits, so notice I have apple, banana, mango, and melon, but it's actually apple, mango, melon, banana being last, but this time banana is brought over here. So you can sort this data. Okay, then you can also change, you can change them. Okay, so you can change them. So changing means you can remove, you can add, and so on. So let's try a property. Okay, so fruits dot let's say insert. Okay, now for a data collection item like a list, tuple, set, they have you are able to access them by using their index. So apple is indexed as 0, so it's like you're counting from 0. Mango is indexed as 1, melon indexed as 2, and then banana is indexed as 3. And then you can count it in the reverse, but this time around starting with -1 for banana, -2 for melon, -3 for mango, and then -4 for apple. Okay, so before we come to the insert, okay, so I can reference apple by using its index 0. Okay, and then it should print apple. Okay, and you can do the same thing for tuple set, and then dictionary. Dictionary is slightly different. I'll come to that. Okay, so I can access it. I can also access melon from the back, from the reverse. So melon, banana -1, melon becomes -2. So I can specify -2 for melon. Okay, and then I can also do what we call slicing. Okay, so maybe I am interested in mango and then melon. Okay, I'm interested in mango and then melon. So how do I reference that? So we can use that by using the slice property. Now when we are slicing, there is a rule. Okay, if I am interested in mango and then melon, I have to first of all specify my first index. My first index has to be the first item I am interested in, which is mango, which is 1. Now, what will be the last index? 2? No, not really. So the last index has to be the index after the last item you are interested in. So my last item is melon, which is index 2, and because of that, in my slice function, in my slice, I would have to specify the index after the last item I'm interested in order to capture the index that I'm actually in. So if melon is index 2 and is the last item I'm interested in, I'll specify banana, which is 3. So it's actually going to ignore the last index. Okay, so the last index, which is 3, so it's going to rather print 2. So when I run, I have mango and melon. What if I'm doing it from the reverse? Same approach, but you do stuff in the opposite way. So instead of me, so I'll start from this. So it's right to left. Okay, so I'm interested in melon, so I'm going to specify the index before the first item, which is banana, which is -1, so to your right, and then the last index I'm interested in is mango, which is -3. So it's going to ignore the first index, which is banana, and then slice the second index, which is melon, and then the last index, which is mango. Okay, so let's see that in action. And then I have mango and then melon. Okay, so I can do that. So knowing this, you can insert. Okay, so let's come back to changing list. So I can insert, so fruits, and you do that by using this function insert. Okay, so what are you going to insert? I want to insert an item before apple. So that means apple is 0. So I want to insert an item in this position. So 0. So what it means is that when I do that, it's going to push apple to the next index, which is 1. So what do I want to insert? Coconut. Okay, so I can print my fruits. And then I should get coconut, apple, mango. So that should satisfy the changeability of a list. Then I can also remove. Okay, so I can remove apple. Okay, so you use the remove function. So a function in Python is allows you to perform, to execute a block of code. So this remove actually is a function which removes a specified item. So these are built-in functions which we don't need to write on our own. So I can run, and then I have just melon, I have mango, melon, and then banana. Then I can do stuff like I can append. So I can append. Okay, I can append coconut. So when I append coconut, okay, it's going to insert or add coconut, okay, to the last item. So it just adds it to the last item. I'm not specifying a specific index. Okay, then you can do things like extend. Okay, so I can extend my data with some other data. Okay, so maybe I can extend my list with maybe coconut and then cashew. Okay, coconut and then cashew. So extend, what extend does is that it adds whichever list item you specify, 2 the variable you are extending to, which is fruits in this case. So when I run, I should have it. Then this could have been in a different data. Okay, so maybe fruits 2, okay, equals to, let's say, this data. Okay, so when you want to extend, I have to specify fruits 2 in the extend function. Okay, and then so on, and then you can sort your data. Okay, so we look at that. So this certifies the changeability of list. And then another property of a list is that it accepts duplicate. So I can have mango at the same time. Okay, so in comparing list to, let's say, tuples, okay, we will come to the difference, but we'll come to the difference. Okay, so I can print. Okay, so I can print fruits, and then the duplicate, okay, should work. Okay, so we have sorry, yeah, so you should have 2 mangoes. Okay, mango, you understand? So list can be ordered, which we did using the sort, and then you can change it, which we did the remove instead, and then it also allowed duplicates. Good. Okay, so what about tuples? Now tuple is similar to list, but there's one big difference, and that is the fact that you cannot change. Okay, you cannot change. So you cannot change tuples. Okay, so let me try some of the tuple function. Let me try some of the list functions on the tuple item. Okay, so first of all, let's try the duplicate. Okay, so list allows duplicates. Tuples allow duplicates. Okay, so if I print fruits for tuple, okay, when I print it, okay, so apple, banana, mango, and then melon. So tuples also allow duplicates. Okay, so what other things does tuple do? Once tuple allows duplicates, tuple have a big limitation. That is the fact that, I don't know if it's a limitation, but the fact that you cannot change it. It's not changeable. So let's say I want to do something like remove. Okay, I want to remove banana. So I'm trying, not even the remove. Since the remove, let me just access a tuple index. Okay, so let's say I want to access banana. So the same way like we did with list, we use the index. So index 1, because apple is 0, banana is 1. Okay, you have that. So let's say I want to print, let me comment this. So I want to actually print this. Okay, so when I run, okay, okay, so okay, so let's okay, so let me comment this. Let's comment this, and then let me comment this. Okay, let's try search file directory. Okay, Okay, so I call fruits. Okay, so we have apple, banana, mango, and then melon. Okay, and then let me try accessing. Let's say 0. Okay, for fruits. Okay, yeah. So now it's working now. So you are able to access it with the same way of accessing list. Okay, so let's say if I know that let me call one banana. So if banana has index 1, what if I try to change? I didn't do that in the list, okay, but you could have done that. So I can specify fruits, okay, and then I want to assign so just to prove that, let me do that with the list. Okay, so let's say I have my list value, and then I want to reassign, or let me say I want to assign fruits. Okay, I think we did that. Don't mind me, we did that, where we assign it with coconut. So I want to assign banana to be coconut. Okay, so I specify its index. Notice that we call the index of banana. So I want to specify that in its index to be coconut. Okay, so basically what I'm trying to say is that take banana and replace it with coconut, and then let me try to print fruits. Okay, so it's going to give me an error. Tuple object does not support item assignment. So that clearly indicates, or that clearly satisfies the unchangeability of tuples. Okay, so you cannot change tuple, you cannot remove it, you cannot insert, you cannot add. The only workaround is you assigning the tuple items. Okay, you converting it into a list. Okay, you converting it into a list. So let me try it, and then try to add all those properties, and then you can convert it back to a tuple. Okay, so that is the only workaround. Okay, that is the only workaround. So let me just try that shortly with you. Okay, so I have fruits: apple, banana, mango, and then melon. Okay, so I'll create another, I'll call this fruits 2. Okay, and this is going to contain the converted fruits, okay, tuple into a list. So how do I convert a list to a tuple? You can just do lists, okay, and then you include the tuple item that you want to convert. Okay, so this is a function here now. It's like a function, and then it's being applied, okay, to convert whatever you have, which is a tuple, into a list. Okay, so when I print fruits 2, notice what I have now. Fruits 2. Okay, so notice what I have now. So notice that fruits 2 is now a list containing the data from the tuple. Okay, then what can I do? I can convert. Okay, I can reassign fruits. Okay, I can so once I have this, I can, let's say, do whatever I want to do. So let's say I want to remove one of the mangoes. Okay, so fruits 2, which is now a list, you can remove. So remove, and then I want to remove mango. So it's going to remove mango. Okay, so let's say run it. Okay, so you have apple, banana, because it takes away the first mango. So once I have this fruits 2, okay, I can convert it back. Okay, so I can reassign fruits 2, okay, to fruits. So fruits here will now be equals to a tuple. Okay, so I'm converting the list back to a tuple. So and this time my list is fruits 2. Okay, fruits 2, which is actually a list. Okay, and then I'm applying the tuple on it, so it's going to convert it back to a tuple. So when I print tuple now, okay, I print the fruits now, it's going to be my new tuple, which has been changed and then worked on. Okay, so basically that is a way of doing that. So even though tuple does not accept list modification, you can do the workaround. Okay, so yeah, so let's look at sets. Okay, so what is set? So your sets, like I said, it's similar to the list and then the tuple. Okay, but there's something about sets. Sets, okay, you cannot change sets, you cannot order sets. It's very strict. The reason why is that set has this, you know, camouflage property, okay, where it keeps changing its, it keeps let me say, it keeps changing the position of its items. Okay, so if I call fruits now, so I have apple, melon, mango, banana, which is not the same arrangement as the initial one. So when I call it again, I now have mango. So initial call was apple, starting now it's mango. Okay, so if this is the behavior of sets, then it's fair enough to say that you cannot even access it with a specific index. Okay, because anytime you call it, it is changing. Neither can you change it. Okay, because when you change and then you call it, it is going to change its position. Neither can you remove and then insert and then do all that. So that is also that is the behavior of set. Okay, now dictionary on the other hand, okay, dictionary on the other hand, okay, you can call it. Okay, you can access it. Okay, because it doesn't change its behavior. I mean, its position like set. Okay, so I can call a dictionary item by using its key. Okay, because it's a key value pair. So if you want to access any item, you are not going to use the item of the index of the item. You are rather going to use its key. Okay, so knowing its key, you can change a value. So I can, let's say, call fruits. Okay, sorry, I can call fruits. Okay, fruits index 1 and then key 1, sorry, and then I want to change it to, let's say, coconut. Okay, so now when I print fruits, notice that coconut is going to replace apple. Okay, so let me run it. So you see you have one coconut, banana, mango, and then so on. Okay, so that is the property of coconut. So what other thing can you do with the list? Yeah, you can let's try, let's see if we can remove. Okay, so let's say I want to remove, I want to okay, so no, I want to clear. Okay, let's try clear. Okay, okay, so yeah, so you see I can clear it, and most of the data collection items allows the clear and then delete. Okay, clear clears the list, and then deletes it permanently. Okay, so yeah, and then you can also sort. You can also sort. Okay, yeah, so yeah, so basically that's the basic work on a list, a dictionary. Okay, so in most of the cases that I have come across, you'll be using the list a lot, especially when you are doing machine learning and data science and then all that. Okay, so that is one thing to take note of. Okay, so you can change the dictionary. Then yes, let me just point this out. Dictionaries doesn't accept duplicates. Okay, so what makes it a duplicate is not the item, okay, is the key. So let's say I have another one, okay, because the keys are unique. So let's say maybe guava, okay. So I have 2 1 keys, okay. So when I call, notice what happens, okay. So call this. So you have one guava, 2 melon, okay. So you see that 3 mango, 1 guava, 2 banana, 3 mango. You see, it removes the first one, which is apple. Okay, so the keys are very unique. Okay, and then they shouldn't be duplicated. So that's all for data collection. Okay, so now let's move quickly to conditions. Okay, so what are conditional statements in Python? Conditional statements in Python allows us to perform an action based on a certain condition. So the first conditional statement is the if else. Okay, so let's say I have x is equals to 100 and then y is equals to 200. Then I want to compare whether x is greater or less than y. So I can write a basic if condition. So if x, so the way we write if conditions in Python is slightly different from other programming languages. So we can say that if x is greater than y, okay, then do something. Print x. Okay, so this is a block of code. Okay, and so this indentation from the first lesson, this indentation tells us that this code, it's under, okay, they are all under this if. Okay, and then notice this colon. Okay, use it when you are writing functions and then all that, just to let you know that you want to continue to the next line, but they are all under the same code. Okay, print x. So let's run and then see. Okay, it doesn't print anything. Okay, why? Because s is not greater than y. So the condition has to evaluate to true before the action will be performed. Okay, so what if we can set, in most cases you may have another condition. Okay, so if the first one fails, you want to check another condition. So you can use the else. Okay, so it's elif. Okay, else if in JavaScript, but elif in Python, kind of strange. Okay, so elif s equals to y, so s is equals to y. So this is from the first lesson we talk about operators. This is what we refer to as a comparison operator. This single equals to is an assignment operator. So we are assigning 200 to y, 100 to x, but here we are comparing x and then y. Quite strange from the normal math that we know. Okay, so print y, print x and then y. So print x and y. Okay, so let's run that code. Still it doesn't print anything because x is not equals to y. Okay, so we can have another elif. Okay, we can have another elif. Okay, and say that if x is less than y, okay, print y. So maybe print y. Okay, print y. So it prints y. Okay, it prints y. Why? Because so yeah, it prints y. Why? Because this condition evaluates to true. So you can have so many else, but what if sometimes you are not certain how many conditions you need to test? So when you are sure, you can decide to cut the number of else, okay, and then you can just say else. So else means doesn't really matter what happens if none of the conditions are so print none. If none of the conditions are above satisfied, then just do whatever function or whatever code that you have here, execute whatever you have here. So when I run it, okay, so print none. Okay, so though this and this doesn't work, print this. Okay, so basically that is a basic if condition. Okay, so what about for loops? Okay, for loops, okay, you use for loop functions, okay, when you want to you want to you want to perform a code, okay, a function based on a range or a set of iteration. Okay, so for instance, if I have fruits, okay, so you normally use it when you are working with list, and you want to iterate or loop through the item. So when I have list, okay, so maybe apple, so let me just copy what I have over here, just be a bit lazy, so let's do this. Good. So I have fruits, okay, and then I want to loop through the items and print each of the items. So you do that by using for, so for or forever, so for, and then you specify a value to use as the iterate, an expression which is x, can be x, y, or anything. So I set up for x in fruits, okay, and then I bring this colon, print x, okay. So when I run this code, okay, it's going to print, okay, so apple, mango, banana, melon, banana, okay. So it leaps through the item, and then, okay, you can also use maybe a range. It could be a range of numbers. So for x in, let's say, range, so this is the function range, and then what is the value? Maybe 10. Okay, so for s in range 10, so it's 0 to 9, making 10. So s in range 10, print x, okay, print x, okay. Or let's say you can say multiply x, okay, by 2. Okay, so let's see what we have. Okay, so good. So you can see that. So it starts with x being 0 multiplied by 2, it's 0. Then x being 2, the print x, yeah, so s being 1 multiply 1 by 2, 2, s being 2 multiplied by 2, so it keeps doing that till it has exhausted the range. Okay, so that is a basic for loops. Okay, so I think I skipped, yeah, so I should have done while loops first, don't mind me. So for a while loop, okay, you can have it's very basic, okay, it's very simple. So for a while loop, you are saying that continue performing a code or keep on performing an action so far as a condition is true. So let's say x is equals to 100, and then y is equals to, let's say, 200. Okay, then we can say that while, okay, there's a while loop, so while x is less than 200, okay, whilst x continuing to be less than y, which is 200, okay, do something. print, okay, print x. Okay, so now this can work, this will work. Okay, so whilst x continues to be less than y, print s. It will work. Why? But you notice that x would continue to be 100 and will always remain less than y, and so it's going to keep on printing and can eventually, freeze your program. Why? Because you have to specify a contingency. Okay, eventually when you are using a while loop, an action will keep on repeating while a certain condition is true, but you have to you have to know when the action has to end, because the action cannot repeat itself forever. Okay, so you normally do that by incrementing. Okay, so we can say s is equals to x plus 10. So after every successful iteration, okay, or looping, okay, you want to increment x so that at a point x is going to be s will no longer be less than y, and then it can stop. So you can use the shorthand. Okay, you can just say s plus is equals to 10. So it's the same thing as s is equal to x plus 10, and so on. Okay, so that is a basic understanding of a list, a while loop. Okay, so next we are going to look at the last thing, which is functions. A function in Python, it's a block of code that performs a specific task. Okay, so in a real world problem, okay, in coding, you would be putting ideas together in functions. So for instance, if you are building a house, you can have a function that loads the block. A function that, let's say, moves the block. You can have a function. That will take the foundation. You can have a function that will lay the blocks, and so many things. Okay. So in Python, a basic function example is the print statements. Okay, that prints something. Then you can have so many functions that's applied on lists, and then so on. These are what we refer to as built-in functions. Okay, these are what we refer to as built-in functions. But you may want to create your own function, and that's what we do as developers. Okay, so this is how you create a function in Python. Okay, so you use def. Okay, so you use def for function. Okay, like define function, and then you input the name of the function you want to create. So I want to create a function that calculates speed. Okay, so function speed, okay, to calculate the speed of an object. Then you need to have this bracket. Okay, so this it's where you can store additional data. We'll look at that. Okay, but you need to add that, and then finally you end it with your colon. Okay, so meaning you are now, whatever you're going to write next is going to be under this first line of code. So when I move on down, then over here I can do exactly what I want my function to do. So I want to print, okay, let's say 100, okay, by 30. Okay, this is what I want my function to do, and then that's all. So let's run my code and see what happens. So my terminal is empty. It didn't print anything. Can you guess? 1, 2, 3. Okay, so I hope you guessed right. So just as we're calling print, we're calling various functions to do certain things. Once you create your function will not work unless you call it. So how do you call a function? Just come outside. We are outside. Okay, so you call the function by just mentioning the function name. So in my case it's function speed, okay, and then you bring your brackets as we've been doing. So now let's run, and then we print, okay, let's run. Yeah, so you print 300, okay, which is the results of the print 100 by 30. Okay, so basically that is a simple function. Now let's just say you want to do more. Okay, so you are going to have different kinds of objects. Okay, so maybe a rocket, a satellite. Yeah, you can have different objects, a car. Okay, and they may have their individual parameters. So notice that speed is actually distance times time, distance times time. Okay, so distance times time. Okay, so we could have just stored the values of distance and time outside our function. Okay, so we could have had distance. Okay, so distance is equals to, let's say, 100, and then let's say 100 kilometers, and then time it's equals to, let's say, 30. Okay, so I could have just say that distance, okay, and then times time, and then you get the same thing when you run. So 3000. Good. So this, while this may be the case, okay, there are certain instances whenever you call the function, you want to supply it with different values. So distance and time may not remain the same throughout. A car can have a different, can take a different time to travel for 100 kilometers. The same way a rocket could take a different time to travel for 100 kilometers. Okay, so the way we do that is to supply all our parameters, okay, variables, whatever you call it, okay, to supply it within this bracket. Okay, so this is what we call an argument. Okay, so an argument, it's an extra data stored in a function. Okay, so distance and then time. Okay, so the function will take two arguments, distance and time, and it's going to multiply the distance and then the time. Okay, good. So what I'll do that when I now call the function, then I'll specify the value of distance and then time. So maybe 100, okay, and then let's say 30. So when I run, okay, I get 3000. So I can call function again, and this time supply it with different values. Okay, so maybe you have like 1000 kilometers. Okay, in 50 seconds. Okay, and then I run, and then I have 3000 and then 5000. Okay, so okay, run it. Okay, so yeah, 3000 and then 50,000. Okay, good. So that is basically a basic function. So what if so there is a way to make this whole thing very simple, to just use one line of code to write this entire function. Okay, and that is what we call the lambda. Okay, the lambda expression. Okay, so what is a lambda? A lambda is a small function. Okay, a small function. So lambda. Okay, so we create a lambda by saying lambda. Okay, lambda, and then so lambda. Okay, and then you specify your argument. Okay, so a lambda will take an argument. So the argument could be, let's say, a. So it's an argument. Okay, argument, and then an expression. Okay, so that is how a lambda expression is written. So let's see that in action. So lambda, okay, and so lambda, okay, then let's say a, and then that's the expression, and then that's the argument a, and then you want to multiply a, okay, a by, let's say 10, okay, a by 10. Okay, then we store lambda in a variable. Okay, so it's a okay, so okay, yeah, so this is the expression s is equal to lambda. Okay, s is, so this is what is going to store the results of lambda, so x, and then lambda argument is a, and then the expression. Okay, so we can print x. Okay, so just as we did in the other function. Okay, so I can print this lambda, okay, and then specify a, okay, which is 5 for me, and then when I run it's 50. Okay, run it again. 50. Okay, so you get 50. Okay, so that is basically in a lambda expression. Okay, so the expression, the format is lambda, okay, the keyword lambda, and then your argument, okay, and then the expression, and you store everything in x. So just as we did in our function, we can have two arguments, so a and b, okay, and then I can multiply a by b, okay, a by b. Okay, so in the main expression I have to specify, two arguments. Okay, so 5, 10, 15. Okay, so let's say this is 20. Okay, 200. So let's see how I'm going to transform my speed calculator in using a lambda expression. Okay, so I'm going to have so the arguments are going to be distance, okay, and then time. Okay, then I'm going to multiply distance by time. Okay, and I'm going to store it in speed. Okay, so print speed. Okay, so let's say 2,000 kilometers in 100 seconds. That should give you 200,000. Okay, so let's try that, and then you have 200,000. So that's all for functions. Okay, so guys, I hope you've learned a lot, and then you wouldn't want to miss the part 3 of this crash course, okay, where we talk, we go deeper, we look at classes, objects, inheritance, all those stuff. We look at modules, very important in Python. So see you, and then out.